Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Physics Paper 1 Higher Tier. Question number 7 from 2023 this question is on the topic of energy, mainly to do with gravitational potential energy and elastic potential energy. Question 7. A baby bouncer is a harness attached to a spring that hangs from a door frame. Figure 7 shows a baby in a baby bouncer in two positions. So in position A, the baby is in the up position, and position B is, you could say, baby is in the down position. The baby bouncer should not be used with babies that have a mass greater than 12 kilogram. Suggest one reason why. Now, depending on the mass of the baby, so if the baby is not moving, this spring is going to extend depending on the mass of the baby. Right? Now, if the baby is too heavy, then the spring might extend way too much. Right? Let's say this is a heavy baby that's shown in position B. If the baby is too heavy, the spring is going to extend too much, and it might go beyond the elastic limit, meaning it might get deformed. It might not go back to its original shape. Or if it didn't, then if the baby is too heavy, then the baby is going to be in the resting position here rather than in position B. That means the baby is not going to be bouncing on the baby bouncer. So any two of those answers will be fine. The spring may become permanently extended, or you could say the extension of the spring may be too great, so the baby's feet are always on the floor. Next part. In positions A and B, the baby is stationary. So remember that in position A it was up, and position B it was down. Describe the energy transfers. Describe the energy transfers as the baby moves from position A to position B. So what is the energy transfer happening at A? When the position is on the up position, the baby has gravitational potential energy. When it goes down, it gains kinetic energy, and when it's in the resting position at B, all of the kinetic energy is then changed into elastic potential energy. And those are your 3 marks. So how do we write this answer? In position A, the baby has gravitational potential energy. As the baby moves down, this is transferred to kinetic energy of the baby, and then elastic potential energy of the spring. In position B, all the energy is elastic potential energy. Next part, 7.3. In one position, the extension of the spring is 8 centimeters. So that's E for extension. The elastic potential energy of the spring is 4 joules. So that's elastic potential energy. Calculate the spring constant, which is K of the spring. Use the physics equation sheet. So the physics equation sheet says elastic potential energy, EE, is equal to half K for spring constant, E squared for the extension squared. Now the extension has to be in meters. How do we change 8 centimeters to meters? 8 divided by 100 gives me 0.08 meters. That usually carries a mark for the conversion. So substituting the values, 4 joules equals half is 0.5 multiplied by K times 0.08 squared. Rearranging the equation, K equals 4 divided by 0.5 times 0.08 squared. That gives me an answer of 1250 Newton per meter. 1250. That brings us to the end of question number 7. I will see you in question number 8.